Okay, folks. Assalamualaikum warahmatullahi wabarakatuh. Welcome again with me. I'm still in here. So today we're gonna talk about 64-bit floating data because this case is actually I've already asked by my friends a lot about this. About 3-4 years ago. I think 3-4 years ago. Yeah. Uh, but right now I'm sorry, I'm just late to explain. Okay, now we first thing first, we will use in this communication with, in this case we're gonna use the serial port RTU because many of you already use the TCP/IP. I think it's easier to set up because you just need the IP address and port, right? So how about to do simulation with the serial port, especially? Okay, so you only need to download this com0com. I think many people already use this. This is very helpful. Okay, I'm sorry for if uh, so many noise here because so many people here. Okay, so you can download this one already. I already installed this on my PC, and then I go on the setup for com0com. Here it's created like two virtual port, serial port, and 4 and 3. This is totally free, so you can download from I think from you can found googling, just googling, then you can find it. Okay, so I will assign this port 3 for the Modbus slave and the com4 for the notepad. Okay, just hit apply and then we good to go. Just minimize it, and here I'm already assigned. If you open the connect, just serial port, and it's shown com0com serial port 3, and then I use commonly used, I'm sorry, commonly used 9600 for baud rate and 8 data bits, non-priority 1 stop bit. Okay, most commonly used. If you okay, this is just a virtual, so nothing to worry about. If in real condition might be, it will impact. So I already assigned here. Okay, in our node red, I'm gonna explain first on the rate that 64-bit floating data. Okay, first we're gonna set this. This is a function code 3 read holding register, but I've start from 0 because it's 0 base. Okay, if you use 1 base, you can use from 1, but in here it will count the first register is 0, from 0, the first register. Okay, so the quantity is 4 because why? Because the 64-bit floating that point data, it will require 4 registers. Each register has 16 bits data, so it will multiply by 4. It will form 64-bit floating point data. Okay, if you talk about if you want to know about the 32-bit floating data point, you can check my other video. Okay, so okay, just okay, now we can see Modbus RTU. I'm gonna check the, okay, this is still new. I think why no data parity bit. Okay, wait, okay, there's a serial export here. Okay, shown parity none. I make sure that everything is same like we already set up on the Modbus slave. And this, yes, com4, of course. And then I make sure all of this check. Okay, because it's really useful for us to uh, like query logging comments. It's useful for diagnostic the connection also. update. And in this optional, I think I'm gonna check all of this, but not using IO file. Yeah, I'm not. Okay, show warning, show activities, everything's okay. Okay, done, good to go. And we'll enable this data. So let me see, we deployed this data, it's connected now. I'm gonna check the output from here. Okay, currently is 0 right now. Okay, I will explain step by step. We change the data to double because double floating, yeah, 64-bit. Okay, it will form like this. So if I send like 3.14, it will show like this, 3.14. 3.14, I'm sorry, my bad English. Okay, so we set the easier memorize the number 1 to 3.4567889. It will form like this, so nothing to worry about. I think so. Okay, because of 4 digits. So what happened actually, this is if I enable this, what actually we receive on the Modbus, it will show here. You can see here the payload. Here's 4 integer, consists of 4 integers, consists of each integer of 4 register, consists of 4 integers. Okay, for each. And then what we're gonna do, we will convert this integer data into separate a register first. Okay, we have to separate this, like it has a payload array 0 1 2 3, so I take this payload 0 1 2 and 3. Okay, and then because we required the binary data for each of this integer, we have to you see here I convert that to string base 2. It means base binary base. Okay, and then if why do I need the substring? Because if we count here, it will consist of 16 bit. So I want to substring whatever I receive. Like sometimes the leading 0 will be missed. Like for example, if you have data, I can write here like 0 0 1 1 0 0 1 1 0 0 1 1 0 0 1 1, for example. Okay, so this 2 leading 0 sometimes will be missed by itself. Okay, so we want the data is actually not modified. Okay, the binary not modified, so just let it shown like 0 0 1 here, like this. Okay, now so for each array data we already convert, and the payload we join all of this. Now this is the pay attention, you're gonna need to know that why do I add this for, we want to form 16-bit 64-bit data from 16 4 I'm sorry, we want to form a 16-4-bit data from 4 of 16-bit data, but we start from the D means like the last array data, and then we last array data, and then we would third, second, and first. Why? Because sometimes you might need to check also your equipment. Sometimes it's like swap byte or swap word. It many happens. Okay, yeah. So if in your case, if the equipment has a like swipe byte or swipe swipe word, yeah, swipe word, uh, just make sure that this sequence is correct, because if not, the conversion will not going uh, uh, so good. Okay, so how to check this? Okay, I'm gonna disable this for temporarily. Okay, now I'm gonna open the Modbus pool here. Okay, the connection ISDRTU COM4, because we already disabled there, so I don't need to worry about. Yeah, okay, we got to go. For not available. Why? Oh yeah, because this is already used by this, so I have to assign this another thing, something like that. Okay. Okay. Now you can see here we write the floating data point here. This 4 consumed by its register. I'm gonna display this as unsigned. Okay, so it's more clear. Then we can see one by one. If I shown here like binary data, it will shown like this. Okay, just make it easier. We only concerned about the first 4. Okay, so what about if I change this double inverse? I will write the same. It will change the sequence. Okay, it will change the structure of this array. So just pay attention of this structure first. You have to analyze first whether it required some swapping byte or swap word. Just pay attention of that value. Okay, so but for this case, most commonly used is double, so we don't convert anything, we don't swap anything, I mean, sorry. So I just write like this. Okay, it's different, it's richer. If you can see on the you can rewind this video. Okay, you can see the structure when I inverse the double. The structure of this binary will be also different from the previous from this one. Okay, so we go back to our Node-RED, Mr. Node-RED. I'm gonna sign again this. Okay, I'm gonna enable this. Done. Okay, now okay, next we're gonna see what we convert. What is when we convert this data, what is the output of this? Okay, we check. I'm gonna check here. You can see here this is a 64 binary data. Okay, that we have formed, that we have convert, and we join each 16th bit into 64 data. Okay, so this is already joined there. So now we only need to take this node. This is a double node. You can download. I can show you. I use, yes, this one, Node-RED contrib double. Okay, this is a very good because it's also convert based on the IEEE754. Okay, so you don't need to worry about where are these guys. Yeah, this one you see here, IEEE750. So then you just make sure that how many decimal digit you want to show, like might be a 16, and we shown here. So that's how we read 64-bit data. So if you want to show this data also, I can make a short dashboard for this. Let me create this text dashboard. Where the hell going? Text, I think text is okay. Yes, this is I forgot, but just shown the I don't know. Is there any impact of formatting data? I don't know. Let us check afterwards. Okay, now update. Not toggle switch. Why toggle switch? Toggle switch? No. Update done. Okay, let's show on the not red. So here is what we got from our Modbus. So you can change also 5 force because of 64 bits floating data. It will have a more precision data. It commonly used on the custody, mostly on the oil and gas. Yeah, oil and gas. The custody transfer. This number is very very important, because if one of the this value will be have a big impact to the uh, invoicing money, something like that. Okay, so that's why this most commonly use 64-bit data. Okay, so okay, we go back to our, we already create our let it be there. So okay, now we already read the data. So how do we write the data for 64 bit floating data? So for example, we inject any floating point, but this number is represent a 64-bit floating point data. So how do we do that? Okay, first thing first, what we're gonna do, we have to convert based on the IEEE754 formula. I have already created this algorithm, so you only need to copy paste this script and then just use it. Okay, just use it, and then afterwards you good to go. Okay, so I don't want to go detail into this algorithm, because you just read this and how this calculation happen, and what is the formula of the IEEE754. Also, you can read from Wikipedia or something like that. I read from what book I read. On the first semester, I think, this calculation. Yeah, at the first semester of my college, I do it. Okay, so you can download. I will upload this flow actually. I will share to you actually. So we check our output of the integer array for this, and I'm disabled this one. Okay, you can see here the output of this conversion function. It consists of four 16-bit of integer data. So each of this is integer data form of the 16-bit binary data. So I already that's the output from the conversion data. And then yeah, you need to read the detail about how is it going on there. Okay, so because it will take sometimes like sine exponential mantissa. I think many of you already know about this, I believe it. Yeah, many of you. So, and then we because we want to push this data into four registers. Okay, we want to force this data, we want to write this data into 4 registers, so you have to use the percent multiple register to write the 64-bit floating point data. Okay, that's why in here I use the preset function code 16 preset multiple register. But we're gonna check again. Yeah, sorry expert, it's just same like that because it refers the same port actually. So in here, just make sure that everything is okay, and yep, we get to go also. So because we start from 0, right, and the quantity is 4, okay, just remember that one, and I will just enable this one. This is just a response, so we don't need to worry about this. Okay, so this is what happened actually. Okay, this is what I write. This is just inject. I think I'm gonna change this like one, 1 2 3 4 5 6, something like that. No, yeah, okay, now it's shown as it is. Okay, so you can use this function script I will share to you. Okay, so or if we want to write this data from the dashboard, how do we do it? Okay, let me show how I do it actually. Sometimes we will disconnect this one. We want to go from numeric data here, and since update from I believe 1.3 not right, we have to change this. Otherwise, if we value, okay, just let it value. Okay, for example, we go to our dashboard over there. Yeah, you cannot write anything here because you cannot overwrite anything. You can only write increase the data. Okay, it will also comes the data from here. So I'm gonna need it should change like message dot payload, and then the strap sorry, and then the step. This is representing the decimal point that precision decimal point that you want to use. Like if you want to like 4 decimal digit, you just only use like something like this, or 5 or 6, you can do it. Okay, so the maximum you want limitless, okay, just 9999 or something like that. Okay, now we deploy this. Now we can write from here, and then we monitoring the value from here. For example, I want to write like 3.14. Yep, it right, see that, or 1 2 3 4 5 6 7 8 9. This polling data, how long, why it takes so long? Let me move my mouse over. It will change or not? No, it's not changed directly. I don't know why. Do you have to press enter or something? Yes, I don't know why this data is not coming directly to the maybe 500. You can adjust this. That's okay. Okay, that's all, folks. If you want have a review, sorry, 1546, it doesn't go directly. Okay, it may take some time. Okay, so that's how we convert the read and write the 64-bit floating point data Just to make sure that I will attach the link on the description below. So if you have any question, you can contact me from LinkedIn or email or something. Yeah, I think so. Okay, you're good to go. Thanks for watching, guys. I'll see you in the next video. Hope you enjoyed. Bye bye. Safety first as an engineer. Okay.